Okay, let's have a look at the next one here. A 182 centimeter tall, 50 centimeter wide, and 100 kilogram teacher is walking at a meter per second directly into the wind, which is blown at 20 meters per second. How much force does the teacher feel from the wind? So I shall represent my teacher as a rectangle, who is 50 centimeters wide, 182 centimeters tall, and 100 kilograms in mass. Now, the tricky part here is that the wind is blowing into the teacher, and the teacher is walking towards the wind. So, think about it like this. If the wind is blowing at 20 and the teacher is walking into it at 1, then the teacher will feel the wind blowing faster than 20. It'll appear, if the teacher was at rest, it would be like the wind was blowing at 21. Consider the opposite. For example, if the wind was blowing at 20 this way, and the teacher was running away at exactly 20 as well, then the teacher wouldn't actually feel the wind, because the wind is only keeping up with the teacher. And in fact, if the teacher went at 21, and no, obviously that's impossible, that's too fast, wouldn't feel the breeze from behind. So, because the teacher is walking into the wind, it's like the wind is going faster if the teacher was considered to be at rest. So, basically, the wind speed and the teacher's speed can be added together, and we can imagine instead of the teacher walking, the teacher is at rest, but it's like the wind is blowing at 21 meters per second. Okay, so how much force does the teacher feel from the wind? So let's look over a time of 1 second. So because the wind is blowing at, oops, it's not a great box, but because the wind is blowing at 21 meters per second, then we only need to look at the wind which is 21 meters in front of the teacher, because that's the wind that will hit the teacher. So what will the force be here experienced by the teacher? Well, the force will be delta P over delta T, but if the T is taken as 1, it'll just be delta P, which will be mv minus mu, which will be just mv. So, like all this air here is at a speed of 21 meters per second, and then slams into the teacher, and the air comes to rest after it hits the teacher. So it hits into the teacher and comes to rest. Sorry, actually, so I have that backwards. That is 0 minus mu. So the air which is moving at 21 meters per second hits the teacher and comes to rest, and the result is the teacher feels a force backwards from it. That would be minus the mass of the air that hits them times 21. Now, let's see. Mass we don't know, but we can work it out, because we know that density is mass over volume. So mass is density by volume. So density by volume by 21. And if we don't care about the direction, I'll just drop the minus. We're told that the density is 1.225 times the volume, which is 21 by 50 centimeters by 1.82, and then that is times 21 again. So this 21 here is the length, and this 21 here is the velocity. Let's put that into the calculator. 1.225 times 21 times 0.5 times 1.82 times 21. 491.6 newtons. Now there is another way to think about it. You can think of this like a gas problem, like a rocket, where the gas is propelling or applying a force to the individual. rather than to the rocket. And you know, for that situation, the formula is the thrust is equal to the mass of the gas ejected per second times the velocity, which is going to be the exact same result here anyways. It's just which way you prefer to think about it. So you can either think about it as the gas is hitting the teacher and coming to rest, and this applies a force, or it's kind of like the gas being ejected from the rocket, and this is given a thrust. Whichever way you prefer to think about it. The way I did it is kind of a little bit more accurate representation of what exactly is going on. So the answer here is, how much force does the teacher feel from the wind? That is 491.6 newtons, which is quite substantial. Okay.